if we are all one consciousness experiencing itself subjectively, suddenly past life memories suddenly make sense. Because if we are a collective unconscious and there's a collective unconscious of humanity, I'm everybody and everybody's me. So in which case, when I'm hypnotized to go back into the 1850s, I'm going to pick up memories either from my DNA, epigenetically, or I'm going to just know because everybody is me. And the reason I do this is my last book, The Hidden Universe. I discuss about entities, I discuss about alien encounters, I discuss ghosts, things like this. What are these things? You know, it's all well and good to say I saw a ghost. Where's the science? What is going on here? Mm-hmm. And I believe that we bring these things into existence by our act of observation. Body can't. Consciousness is non-physical. Consciousness does not have extension in space. I would argue that consciousness is a wave, and my brain, effectively by attending to the consciousness wave, collapses the wave function of consciousness within my brain. My brain is a receiver. And that means that consciousness can be anywhere.
Hi, Anthony. Welcome to United Planet. How's things, my friend?
Great to see you again, Paul. Yeah, no, things are good. Very, very busy. New book I'm writing at the moment, plus an essay I'm writing. So there's lots happening at the moment. Lots of events coming through. It's all quite extraordinary considering we're supposedly in lockdown. But that's the tragedy really, is that one thing we can't be doing is live events. But one of those things. But no, there's an awful lot on. Life is exciting, if somewhat hectic.
That's good. You know, especially like say in lockdown, it is just more exciting as well, which is good because you can be a bit Groundhog Day feeling in lockdown, but at least it's exciting for you. That's good.
Yeah, Groundhog Day. I like you using the term Groundhog Day, as you know my whole opinion on Groundhog Day or Groundhog Life. In fact, I just posted something on my Facebook wall about Groundhog Life because the title of the Russian language edition of my first book, Is There Life After Death, was actually called Groundhog Life, a Chronicle of Your Many Lives, which I thought was very, very good.
Wow. Yeah. Excellent. And so you're writing a new book at the moment, in the process of writing a new book?
Indeed, yeah. It's book 13. And it looks like I've already got a book deal with a fairly large American publisher for one, maybe 2 or 3 books as well after that. Uh-huh. So it's exciting times. The new book will be a complete update of my cheating the ferryman hypothesis, taking into account, because you probably may not recall this, but the original cheating the ferryman concept was in an academic, peer-reviewed academic paper that I wrote in 2004 and was published in December 2004 in the International Association of Near-Death Studies IANDS journal, and that introduced the concept of cheating the ferryman. I then subsequently, quite a few years later, well, 2 years later at least, I think, managed to secure a book deal with a publisher, Arcturus in London, and that book came out under the title of Is There Life After Death? The Extraordinary Science of What Happens When We Die. But the new book will be taking into account, because subsequent to writing the first book, I've now been approached over the years by scores of academics, scores of researchers, and of course I've had the opportunity to read dozens and dozens, hundreds probably, of academic papers, and also extended the ideas in terms of the science. And I feel that now is the time for a new book to come out, which will be taking into account a lot more of the science of my cheating the ferryman hypothesis. And this is what the new book will be about. So it will be putting the real science in there together with the advances that we've made in our own scientific understanding of the world, but specifically to relate to the growing ideas I have in terms of the simulation argument, the idea that this is some form of projection, but also doing the science of it, because, you know, I will always do the science first, you know, where people turn around and say, oh, the universe is holographic in nature. Yeah, all well and good, but explain exactly what you mean by that. Where is the science that supports that? Who are the scientists that are supporting that? And indeed, to try and explain in layperson's terms why we believe that there is strong evidence that this is holographic in nature. Because, as you know, Elon Musk made a statement around about 2 years ago about this, and the press got really excited, but nobody bothered to then explain how powerful the science is to support this seemingly crazy idea.
Well, it's not crazy. I think you're actually right, and I believe it's also holographic as well. So, I mean, obviously, I've had my near-death experience when I was 14, so I saw things similar to what you're explaining. So, I can understand that. So, so in regards to the holographic universe, so who do you think is actually making that, or are we ourselves in the future making that, or what's your take on that?
That's the million-dollar question. It depends which approach you take. There are two separate fields of investigation here. There is the initial field of investigation, which is doing the science of how it could be that this is some form of projection. And I'll go on to that in a second. This is to do with black holes, it's to do with information theory, and it's to do with the second law of thermodynamics. But there is also the alternate argument, which is the simulation argument of if it is a simulation, if it is in fact made of data, who is creating it and who's doing it. Now, around about 1995, a Cambridge academic called Nick Bostrom, who's a mathematician at Cambridge, was, I think, the first person to really put this idea on solid ground. And he wrote a fascinating essay about, are we living in a simulation? And his argument was quite an interesting one. And he said that, let us discuss human progress. And particularly, let's apply something called Moore's law. Now, Moore's law was put forward by a guy called Moore, who was one of the founders of Intel in the mid-1960s. And Moore argued that effectively processing power would double every 2 years. So every 2 years, the processing power available to computers would double. That, until about 3 or 4 years ago, continued, and it's now extrapolated out to about 3 years. And it's only restricted effectively by the size of how many things we can get on a printed circuit board. And, you know, microtechnology, nanotechnology now is progressing to such an extent that we can do more and more. More and more, pun, I shouldn't have made that one. But also on top of that, we now have the other opportunity, which is quantum computing, which I'll come into in a second as well, which makes things even more interesting. But what Bostrom said was, so imagine a scenario that in the future, and I've done a calculation on this, and I know how much data and how much processing power would need to simulate a universe. Now, again, a group of German researchers, which literally in my new book which literally only 2 days ago I was reading about this, reading deeper into it than I should say. I knew about it, but reading deeper into it, have managed to simulate a very, very small part of reality, like we're talking in femtometers, you know, really tiny. But there's no reason why we can't restrict outwards, and there's no reason why the processing power isn't available to us to expand outwards to processing information for things as large as microbes, and bigger as time goes on. But if we apply Moore's law, I calculated that around about 250, 300 years, the processing power available to us would allow us to create what Bostrom calls ancestor sims. You know the computer game of The Sims.
Yeah.
And the idea is that if we do not destroy ourselves in a nuclear conflagration, or we're not wiped out by things like COVID or whatever, what would scientists do with all this processing power? Well, we know what we do with the processing power. We create simulated worlds. We have already done it. I mean, there is No Man's Sky, which is this huge, I don't know if you've ever seen No Man's Sky. It's a simulated universe. It is literally a computer game online that you have millions and millions of planets, and you can travel in that universe and travel to these planets. You can find your own planet and populate it and do what you want with it. So clearly, you know, from the computer game The Sims onwards, we have been intrigued by this idea of creating simulated realities. We also know from the popularity of things like Second Life that the idea of putting yourself into a simulation is incredibly beguiling and effective. Now, around about 6 or 7 months ago, I acquired one of the new Oculus VR headsets. Now, with the new Oculus headset, you don't need a laptop to be attached to it. All the processing power is in the headset. And already there are virtual reality worlds similar to Facebook, whereby you can actually meet up with people in a 3-dimensional world and I visited there on 2 or 3 occasions, and it's quite uncanny because you're in this real place, you're wandering around, it looks as real as you can imagine, and you're wandering around, somebody will approach you, and it's in 3 dimensions, and you get talking to this person, and you realize, like I did once, and he's somebody from Japan, and he's a Japanese guy, and we're talking to him, and then somebody else appears and joins us, and you're having this conversation in 3-dimensional reality, and there is no way. If you suddenly, as I've said in one of my essays, if you wiped your brain clean of all your past life memories and placed yourself in one of these simulations and not being aware you were in a simulation, there's no way you could tell. You would believe this was real. Okay. And I believe this is where we are now. And this is the point, one of the points I'm making. But going forward, Bostrom said, so what would they do with all this processing power in the future? Well, they create ancestor sims. And what would they populate those ancestor sims with? Us. You know, reincarnations of ourselves. Now, it is not beyond comprehension that somebody could scan your brain now, scan it down to the molecular level or to the subatomic level, scan it in great detail, digitally reproduce all that information, then download that into a computer program. Now, the question is, and it's a hugely massive question, is that then you? If you then die, is that downloaded you or not? Now, of course, one of the major problems is something in philosophy is called the substrate problem. The substrate problem is like the Turing test. Have you ever seen the film? Is it? I can't remember now. It's a young guy, software engineer, who goes off to this guy's place on an island, and this guy is a top artificial intelligence guy. It may be called just AI, I'm not sure. And he's got this robotic person who looks human. Effectively, she looks human. And the question is, can she pass what's called the Turing test? And the Turing test is, by asking questions of somebody else, could you tell whether they were actually a real person or a computer program? And there's no way of knowing.
Hello.
Hi.
I've never met anyone new before. Have you?
None like you. She's incredible.
The challenge is to show you that she's a robot and then see if you still feel she has consciousness.
You know, there are things now that may pass the Turing test, but the problem is, are they just zombies? We think they are alive and conscious, but we can never tell. Because ultimately, we can never tell whether other people are conscious or not. You know, it's the problem of other minds. It's been in philosophy for years. So anyway, if the argument is that if they can overcome that, and I think they can't, but if they can, then they would populate those worlds with you and I. And what would they do? Well, like we do, we just set it running, like people do with the Sims. They just set it running and see what happens, which means they would stimulate multiple universes with different versions of the universe evolving in different ways. Now, the latest theories, there's some fascinating theories in my new book. I'll be talking about these in greater detail. You know, there's the Everett's many worlds interpretation idea from 1957, Hugh Everett III, suggesting that the universe splits into multiple copies of itself billions of times a second. And in each of those universes, there will be a Paul and an Anthony. And we'll be having this discussion in multiple universes with subtle differences. Then we have the Alan Guth inflation theory, which says that we have bubble universes that are continually bubbling off this universe. But both hypotheses both conclude the same thing, that anything that can happen will happen. So everything is programmed in for things to evolve in certain ways. Okay, so that's the one side, which is the side of the ideas of it. And various other people have taken this on board. But what people on the simulation argument side do not follow through is, well, how will the science work? You know, we've got the processing power, but we're still at the first base. And this is where you start looking at this universe itself. And there's some very strange things about this universe that don't make sense, or do make sense if you believe it's a simulation. Now, it all goes back to black holes, believe it or not.
Okay.
And the role of black holes. Now, a black hole, as you know, is something that is so dense, its matter is so dense and so converted into itself that the escape velocity, for instance, when you want to leave the Earth, you need an escape velocity of about 24,000 miles an hour. That is what the Apollo spacecraft, when they went up in the 1960s and 1970s, they needed to get to that speed to break away from the gravitational pull of the Earth. Okay? Now, a black hole, now gravitation effectively is just a question of mass. The greater the mass, the greater the gravitational pull. So the Earth has a mass and the gravitational pull. The moon is a smaller object, so it's pulled into the gravitational pull of the Earth. The Earth is smaller than the sun, so therefore the Earth revolves around the sun because of the gravitational mass of the sun. But imagine a scenario where there is something so dense that its escape velocity is greater than 186,000 miles per second, the speed of light, 300,000 kilometers a second. If that was the case, light couldn't escape. Even light would be bended back, and that's what a black hole is. That's why it's called a black hole. It literally is so dense that nothing can escape from it. And of course, as Einstein said in his general theory of relativity in 1915 or whatever it was, that nothing can travel faster than the speed of light. So nothing can escape from a black hole. So everything gets sucked into it. Now, the problem is recent research, and it's really powerful stuff. There's some fascinating work being done at the moment. Information is physical. Data is physical. Binary information has a physicality about it. And again, if anybody's interested in this, look at the work of people like Claude Shannon, 1950s, and right through now to some of the latest researchers like Vlatko Vedrell, who's a British Serbian quantum physicist. He wrote a book a few years ago going into great detail about this physicality of data. So I take my phone and I'm on the edge of a black hole, okay? And I take this phone and I throw it into the black hole. Now, if we believe we exist in an enclosed universe, that is, there's nothing outside of the universe. That's what's called an enclosed system. There is nothing outside of it. In any enclosed system, according to the second law of thermodynamics, energy can only be converted into another form of energy. It can never be lost. It's the conservation of energy law. It's across the universe. If I take that phone and all the information on it and all the data and all the photographs and everything else, and I throw it into a black hole, what happens? That phone disappears, which means that information and energy has been lost from an enclosed system, which is scientifically impossible. Stephen Hawking was intrigued by this and discovered by doing calculations and everything else, mathematically, he proved that black holes shrink. And black holes do not just take everything into them. When that phone is thrown in, the theory is that that phone, part of the phone will be sucked into the black hole and destroyed forever. But the digital imprint of that phone, the information on that phone, will be smeared out along the edge of the black hole. So all the data will be smeared out. Now, they've extrapolated from this and said, imagine that since the Big Bang, 13.7 billion years ago, everything expands out, isn't it? It didn't expand out from a single point, by the way. The universe is every point in the universe is expanding out from every other point. It's not as if it's from one point. But effectively, imagine the universe was like a balloon being inflated. And it's been inflating for 13.7 billion years. If you imagine that, it's like you're inside a huge bubble or inside a huge balloon. Now imagine the inside wall of that balloon. It's an extraordinary calculation, and how they've done this, I do not know, but I have checked this up, and it is a valid calculation. They've made a very interesting discovery. It has been suggested by people like Juan Maldacena and the late great Israeli quantum physicist, cosmologist Jacob Bekenstein, that the surface on the inside are dotted with tiny Planck squares. Now, I'll explain what a Planck square is. The Planck length is the smallest possible bit of space that can exist. You know, you drill down, you get smaller and smaller and smaller, and you go way past the molecules and way past the atoms and way past the quarks, and you continue getting smaller and smaller. There is a ridiculous amount of size that we do not know what's there. But when you eventually get to the one point, matter, there's no more space available. Okay, that's called the Planck. But of course, a length is just a line. So to be an area, it has to be a square. Okay, to be two-dimensional, it has to be a square. So one dimension is a point, then 2 dimensions is a line, and 3 dimensions is a square. Okay. If you take the Planck length and you have 4 of it, you're in with what's called a Planck square. They calculated that if each Planck square at the edge, by the way, it is Planck, not Planck, it's Planck. You know, I know people criticize me sometimes pronounce that's how Germans pronounce it, and I'd prefer to use Max Planck's name the way he pronounced it rather than the way people pronounce it. Just like it's quarks rather than quarks as well. Yeah. Murray Gell-Mann said it's quarks, so if that's what Murray Gell-Mann, who invented the term, wanted, that's fine. So each of the Planck squares are really tiny, really, really tiny. But they've suggested that if each one of these is like the edge of a black hole and contains 1 bit of information, how many bits of information could be projected inwards from the edge of the universe? And they have found, how they found it, I don't know, but they've calculated how many bits of information would be needed in order to encode this universe. And it's exactly the same number as the amount of Planck squares on the end of the universe. And when they discovered this, they went, what's the chances of that? That is extraordinary. And there was the sudden realization that what is actually they think is happening is that, and I know this is going to be hard to accept, but again, if you read Scientific American on a regular basis, and there was particularly a few years ago, a Scientific American that said, "Oh, we're living in a hologram." It was on the cover. So this is hard science. This is not loony bin stuff from the guy down the pub. Okay, that the information is being projected inwards, and that information creates what we think is a three-dimensional space-time continuum. But it's actually created out of 2-dimensional images because it's on a flat surface. So the sense of depth that we have, the sense of distance we have, is all an illusion. It's all given to us by our brain processing this information that's being downloaded into us. And I argue in the new book that in many ways, each of us is our own virtual reality processor. And each one of us is processing the information and creating this external reality around us by downloading it and then expanding it outwards. As if, you know, the brain, like your computer, when it's running a virtual reality thing, the virtual reality that you're seeing as a 3-dimensional virtual reality in your virtual reality headset is in fact just a line of digital code. There are no cows or fields or monsters or zombies out there. It's just digital code. What changes that digital code into the thing on your screen is your processor. And your brain is processing that digital information outwards. Now, it means that each one of us is processing this outwards. But I argue in my new book that each one of us is contributing to that external reality. So we are collectively creating from data what's called consensual reality. You and I are now creating it now. When we're in a football crowd, we create a greater one. But effectively, on your video camera now, you can see behind my head. You can see all the books behind my head. In my world, I don't need to do that. I don't need to render what's behind me because I don't need the data. It's only when I turn around it's rendered. Somebody called Tom Campbell argues this in his book on My Big Toe. But I think I take this further. And I suggest that, and what I'm calling the reality we perceive, I call it the egregorial. The egregore. And the reason I do this is my last book, The Hidden Universe. I discuss about entities. I discuss about alien encounters. I discuss ghosts, things like this. What are these things? You know, it's all well and good to say I saw a ghost. Where's the science? What is going on here? And I believe that we bring these things into existence by our act of observation. Now, just as a final point, to just continue just a little bit further with the science of this. According to the Copenhagen interpretation of quantum physics, which is the main, it's called the standard model of quantum physics at the moment. It is argued, and again, if people have never heard of this, it is extraordinary, that everything that's out there only comes into existence when it is observed. Okay, this again is hard science. It's proved time and time again by something called the twin slit experiment. You know, this is experimentally proven. The question is whether the act of observation is just an object doing the measuring, or whether it's the mind that is ultimately processing. Because if I measure something with a ruler, the ruler isn't doing the measuring. I'm doing the measuring because I'm looking at the ruler and saying that's 8 inches long, isn't it? So the ruler is nothing. It's inanimate. It doesn't do anything. So the argument is that if you take any measurement, ultimately it comes back to consciousness. Now, what takes place is that ever since Max Born came up with his arguments, everything that is physically out there literally exists as a statistical chance of being in one place or another. A subatomic particle statistically can be anywhere in a box or anywhere in the universe. When we observe it, it collapses from being a statistical wave function to a point particle with a location in space. And this is called wave-particle duality. It's the idea how light can be light effectively, for instance, is a wave until we observe it, and then it becomes a particle. This is extraordinary science, and this is mind-blowing in its implications. It means effectively every bit of light you see is a wave. Now, a wave is something in something else. A wave in water is smeared out. Okay, where a point particle is a point in space.
Right.
How can they be both the same? But they are. A wave becomes a particle because it's observed. Now, this means something extraordinary. It means that whatever reality is out there, because remember, what you're seeing now is literally photons of light. That's point particles of light stimulating your retina. And that's what's creating the visual world you see around you. But if you're not seeing those point particles, they're waves. So again, the relationship here is far more curious than people like Brian Cox would have us believe, that they've sussed it all out. You know, Coxey brought out a book a few years ago with a person I've done an event with, his PhD tutor, Jeff Forshaw. And the subtitle of the book was "Everything That Can Happen Will Happen." And nobody read that. You know, nobody realized what is Coxey saying here. And Coxey stood up, I think it's 3 weeks ago on the Breakfast Show, and he made the same comments I've made. This is a simulation. Coxey said that. Why that wasn't headlines with all his fans going, hold on a minute, this is the guy that disses telepathy, disses all these things, and it's believed by idiots. Yet he's arguing that we're living in a simulation and that everything that can happen will happen somewhere in the universe. And that's true. It's to do with Alan Guth. It's true with inflation theory. So everything I'm saying now is absolute science. Absolute science. I'm not saying I'm downloading it from the planet Tharg, or some the Pleiadians came down and told it me, or Seth is talking through me. No, this is the science, and you can read any book on science and make your own conclusions about this. So this is extraordinary. So this suggests that this world is definitely not what it seems. So when you discuss your near-death experience, suddenly what happened to you suddenly starts to make sense, because if this is one of many worlds, these worlds abut each other, they are close to each other, they can be traveled within these worlds in certain ways, because their argument is, you can't, the scientists would say you cannot travel between the bubble universes, for instance, Alan Guth's inflationary model. Whoever at the third would argue that once you're in one particular Everett universe, you can't transfer into another. Physically, you can't. Your body can't. Consciousness is non-physical. Consciousness does not have extension in space. I would argue that consciousness is a wave, and my brain effectively by attending to the consciousness wave, collapses the wave function of consciousness within my brain. My brain is a receiver. And that means that consciousness can be anywhere. Now, imagine, for instance, that our consciousness is related to light. Imagine that consciousness is like light. It's a wave and it's a particle. Two things about light that is fascinating. The photons of light, which are the signal carriers of light, are very interesting things, even when they're not being waves. They are point particles, and people use this term point particle without really fully understanding what it means. A point particle is something that however much you zoom into it, however much you magnify it, it will always be a point particle. You will never see a little sphere or anything because it just continues to be a point. Now that in itself is weird, which means it has no extension in space. It means that it doesn't have, and it doesn't have mass. Photons do not have masses. Some arguments they may have, but generally photons do not have mass. But what is weirder about a photon is it can only ever travel at the speed of light. That's all it can travel at. And I always argue this to people when they say about that, well, why is that not weird? And I'll say, hold on, if I get in a car and my car can only travel at 50 miles an hour, how do I get from being stationary to being at 50 miles an hour? Mm-hmm. Whereas science will tell you all the time, light can only travel at the speed of light. So if I switch a torch on, surely how does the light start here? Mm. It must accelerate to get to 186,000 miles an hour, but it doesn't. It's immediately traveling at 186,000 miles an hour. At 186,000 miles per second, at that speed, something very strange happens. Space becomes time. There's something called the Lorentz contraction. And the nearer you get to the speed of light, space turns into time. Space and time are the same things, and one can be converted into the other. But the ending of this is, as you get to the speed of light, time stops. Time absolutely stops. At the speed of light, there is no time. Wow. If there is no time, how does the universe look from a photon's point of view? Say you had a sentient photon. That photon will have been in existence since light was created around, I think, around about 13 million years after the Big Bang. I'm not sure, but it wasn't created at the start of the Big Bang. Mm-hmm. But from the point of view of that photon, it's the same second. A photon leaving Aldebaran, the star, and entering your eyes, as far as that photon's concerned, it's instantaneous. Mm-hmm. Which means that everything that makes us see things exists in a different world to us, even though this is what makes us see. So suddenly the universe is starting to look weirder and weirder and weirder. And I believe we are now starting to break out.
Sorry. Parrot. Sorry.
Oh, right. Okay. We're starting to break out of this naive worldview and this kind of hubris that we know everything, that we understand the science now. We understand the implications of the science. No, we don't. And we don't because we have to start thinking differently. We've got to break away from the materialist reductionist model and argue that the biggest mystery is consciousness, how consciousness works, how the brain creates consciousness. And I genuinely believe, and I know it's going to sound vain, but I think I'm the only writer on the planet that's doing this. There is nobody doing what I'm doing. And all the time I'm bouncing up and down, going to the world and saying, hey, world, you know, there's books come out now and people will go crazy on them. These books contain stuff I was writing about 15 years ago and nobody wanted to know, and I think there will be a time when somebody will go back on my books and say, hell, this guy really, he may have been off on the tangent in some of them, but at least the questions he was asking were powerful ones. So that literally then, so that suggests that this could be a simulation. So we have the two elements, don't we? The simulation argument from the scientific evidence and also from the perceptual as well.
Mm-hmm. Wow. You just got me going in my head now about consciousness. So, I mean, how do we get conscious? Is it like from birth? Do we get that spark of light, and then while we're in our mummy's womb, how does that happen?
Well, again, I think it was 1999 at the University of Arizona, a young Australian philosopher called David Chalmers stood up. I'm never sure if it was 95 or 99. I think it was 99. And he said there are two major problems with science at the moment. There's the soft problem of science, which is how the brain works, how the neurochemicals react to each other and everything else as well. Mm-hmm. But the hard problem is insolvable. And the hard problem is how the brain creates self-referential consciousness. Because people argue, and people will turn around to me and they say, I get this argument all the time, and it's quite pathetic. And they'll turn around, and scientists will turn around to me and say, it's a transition phase. He said, it's rather similar to how gas becomes a liquid. And consciousness is a transition phase. It's not like anything else because it sort of comes out of something. Well, I'm sorry, but the last time I looked, atoms and quarks and everything else weren't anything like consciousness. In other words, gas and water are the same things. We know that. Whereas self-aware consciousness has no similarity whatsoever to the chemicals and the fields in my brain. It's a completely different thing, isn't it? Mm-hmm. It's completely and utterly different in every shape or form. So how they get around this, it's really funny how they get around this, how the scientists get around it. They cite something called eliminative materialism. And eliminative materialism, get this, is that none of us are conscious. This is serious. This is the serious science that academics, this is serious academics. This is the level of idiocy you have to deal with. Because they're so down their stupid route that they cannot get off it. That you and I are fooling ourselves into believing we are conscious. We're not conscious of anything. We're not aware of anything. We're just unthinking automatons that think we're aware. We're being fooled into thinking we're conscious. People like Daniel Dennett. He wrote a book, a hubristic book called Consciousness Explained a few years ago. About 2001, something like that. And he says, I've explained consciousness. Oh, of course you have, Daniel. Of course you have. And in the argument, this is what he uses. He's a limited materialist. He believes that it's all being fooled. And as I've said in one of my books previously, so if I fool a dog into thinking I'm throwing a ball in front of it and it runs after it, I've fooled that dog. But that dog is conscious of the fact. It's acting upon what I've done, which means it's conscious. Yeah. But Dennett et al. Are saying we can be fooled even though we're not conscious. So how can I can't fool a rock. Mm-hmm. This is the level of the lack of logic and idiocy that we have here. So clearly what they say, the question then is, well, how does chemicals reacting with fields in Paul's brain and Anthony's brain create our sense of selfhood, create our awareness, our ambitions, our hopes, our dreams? How does chemicals reacting with energy create the smell of a rose? People will turn around and say, well, yeah, because the smell of the rose is out there. No, it's not. Nothing smells of anything. There's no such thing as colour or anything. The smell of a rose are chemicals. Mm-hmm. But the chemicals themselves do not smell. Mm-hmm. What smells is when those chemicals come together and our brain interprets those chemicals as being a smell. But smell is nowhere. Okay. Neither is the colour red. The colour red is just what our brain interprets as being a particular vibration of the electromagnetic spectrum. There is no red out there. There's no blue out there. There's no green out there. And anybody that believes that is actually called a naive realist. That's the terminology that's used for somebody that believes there's a one-to-one relationship with what's out there, which is what is inside. So there is something inside all of us that is processing this information. But it's not only processing, it's like vision. It goes into your head, and somewhere in your head, the little belief is that, there's a little version of you sitting in a little room, and it's got a pair of speakers either side, and it's got a TV in front of itself, and it's looking at it and going, oh, that's the world. Remember the numbskulls? You're probably too young to remember the numbskulls. But the numbskulls idea, the problem there, that causes an infinite regress, because if there's a little numbskull inside your head, that little numbskull's got eyes and ears. So he must have a little numbskull inside of him. And this is the argument that people like Daniel Dennett uses to say that, you know, the idea that there's an inner anything is nonsense, because whenever you look for the inner anything, you can't find anything. But every single human being on the planet knows he's wrong, because we know we think and we are, and everything else as well, as long as we can get over the problem of everybody else being zombies. But if you fall into that, you fall into solipsism, and then you've got a great danger, because then you believe everybody else is just an hallucination, which is, again, one of the other areas I argue that there's strong evidence to suggest that that is the case. But the counter argument to that is, no, they're not. And the reason they're not is we are one consciousness experiencing itself subjectively.
Absolutely.
So the problem of other minds disappears when you apply that. You know, it's just that we are embodied part of a greater consciousness, you know, what the Kabbalists would call the Or Ein Sof, or what, I don't know, the Vedantists would call Brahman. You know, it's the idea that there is a singularity, and we're all experiencing something subjectively, and we're within the simulation. So we are the simulation. As John Archibald Wheeler argued, a very famous quantum physicist, in fact, the PhD tutor of Hugh Everett III, whom I'm quoting a lot in my new book. Wheeler was amazing. Wheeler's actually proved, using logic, that not only the act of observation of collapsing the wave function brings into existence the visual world you're seeing now, it also brings into existence things that happened billions of years ago. And again, he does the science of this. And if anybody's interested in, just read up. It's called gravitational lensing, and it's called the delayed choice experiment. Again, you won't find this probably in New Age wacko books about channeling stuff from the planet Tharg, but if you pick up a book on physics, hard physics, you'll find it. And it's, as I say, it's called the delayed choice experiment. It is extraordinary. So consciousness clearly is a great mystery. Now, you said, when does consciousness appear? In one of my books, I use the analogy, and I said, okay, let's extrapolate this. When does consciousness appear? If consciousness is created by the brain, does consciousness kind of just tune in like a signal? You know, you slowly become more and more conscious as you come out of sleep. And is that as the brain gets more complex and you have more neurons are communicating? Does that happen? Or does it just happen spontaneously? You know, the addition of one molecule, and suddenly consciousness is just there. And it's when you drive it down to that it becomes crazy. It doesn't work anymore. It's again the idea of how something totally non-physical, like a thought, can have any kind of relationship with something that is physical. But of course, then you have the huge problem of, how do I do that? How does something non-physical in my brain, which has no extension in space, and within science we have this idea of cause and effect. You know, I push something and it reacts. So you have to be physically in contact with something to make it happen. How can you do that if you are a non-physical something? How can you physically make your nerves move in order to make your hand grasp something? How does that work? And that's a huge, huge mystery. And it's a massive mystery. Nobody has an answer to it. It's again one of the things in my writing, I always point these things out. Science is not even at first base in understanding anything. We're in a Heath Robinson science, whereby in medieval times there were a thing called epicycles, which the medieval schoolmen believed they could explain how there was retrograde motion in the outer planets, because of course they believed the Earth was the center of the universe and planets just went round us. But the problem was there were certain planets in the sky that during the year would go in one direction and go back on themselves. And they couldn't explain that, because they thought, well, how can that be possible? Because if they're going around the Earth, and they created things called epicycles, which were kind of little cycles that they went round. And then they built this incredibly complex science explaining this. And to them, it worked. And then Copernicus came along and said, applying Occam's razor and the most simple explanation, I can explain it because the sun is where they all revolve round. And from our viewpoint, it would look like they were going backwards. And suddenly all the science that they had that they thought was right evaporated. And this is going to happen to us. In a few years' time, what's going to happen is there is something called Thomas Kuhn came up with a concept called the theory of scientific revolutions. And the argument is that there are so many things. We can't explain dark matter. We can't explain dark energy. 94% of the universe is missing. What? Do we know what it is? No, but we know it is because how the galaxies revolve. We know there's something strange out there. Do we know what it is? No. So we give it a label. We call it dark matter and dark energy. And then people like you and I can go, oh, scientists have got it sussed. They call it dark energy. So they know what it is. They call it dark energy because they haven't got a clue what it is. You know, it's peculiar in many ways, and it is something that it's because they have invested their whole lives in doing something, and their credibility depends upon it, and they cannot be seen to be saying we don't understand it. Like, for instance, quantum physics should be taught at schools. Everybody should know this. Everybody should know that in 1981 in Paris, two guys, Alan Aspect and a guy called Dalibard, did an experiment at the Institute of Optics, which proved non-locality. It proved that if you do one thing to one object, another object, if they have been entangled, the other object reacts instantaneously. It's called what Einstein called spooky action at a distance. They've been doing experiments on this for years. There's a guy called Anton Zeilinger at the University of Vienna has been doing experiments on this for years. The things they can now do is extraordinary. But the man in the street is just not told about this because it's so inexplicable. But it is explicable if you think about this. As Richard Feynman once suggested, semi-jokingly, why is it that every electron in the universe looks like every other electron? All subatomic particles are identical, absolutely identical. Feynman once said jokingly, do you know why I think they're identical? The universe is made out of one electron traveling backwards and forwards in time.
Wow.
Okay?
Okay.
Now, that is a profound statement because suddenly we're getting into philosophy here, but it would explain why they all look the same. And it would also explain why if you did one thing to one particle, the other one would react in the same way. Now, make a final point here. You know, I was talking about one consciousness experiencing itself subjectively.
Yeah.
Entanglement is when subatomic particles are put in the same quantum state, when they're in close proximity to each other and everything else as well, pushed down. At the point of the Big Bang, everything that exists, every single atom, every single molecule, every single quark was in a point particle. And again, remember, I was going back to point particles. The universe was a point particle, which was, get this, if you read the science books, they'll say the universe started from an infinitely small, infinitely tiny, infinitely zero mass point. I've always wanted them to explain exactly what you mean by infinitely small. How can you have infinitely small? It doesn't work. You can't have infinitely small. It means nothing, does it? It's just words. But the idea is that this infinitely small thing contains everything. Contains the glass in your glasses. It contained the rim of your glasses, the feathers of your parrot. Everything that configures that was in this point particle. If that was the case, everything in that point particle was entangled. And if everything was entangled then, and we know from science, if you entangle two subatomic particles, they know each other's existence. Now, again, Jeff Forshaw, Brian Cox's tutor, told me over coffee at the University of Manchester before we were planning to do an event at the National Theatre in London. This is the place where they split the atom, and he's the professor now of the same location. Okay. And he turned around to me over coffee, and he turned around and he said, well, we now know that every electron in the universe knows the location of every other electron. Now get that. Think about that for a second. Every electron in the universe knows the location of every... And I've heard Coxey say this subsequently. It's not him. It's his PhD tutor. Okay, so what does that mean? Well, that means they're all entangled. So suddenly telepathy that Coxey thinks is a load of crap. Well, if things are entangled, why can't things be telepathic? By your own science, why can they not be telepathic? if we are all one consciousness experiencing itself subjectively, suddenly past life memories suddenly make sense. Because if we are a collective unconscious and there's a collective unconscious of humanity, I'm everybody and everybody's me. So in which case, when I'm hypnotized to go back into the 1850s, I'm going to pick up memories either from my DNA, epigenetically, or I'm going to just know because everybody is me. Mm. And suddenly the world seems to look in a far more interesting place.
Yeah, absolutely. I get that. And so do you actually believe in reincarnation? I mean, do you feel like you could have been...
I have great problems with reincarnation. Mm-hmm. Do I believe that theoretically it's possible using that argument? Yes.
Mm-hmm. Yeah.
Do I believe that reincarnation makes any logical sense? No, I don't. Mm-hmm. And I do that for one very good reason. What is the point of being reincarnated as somebody else, miles away from where you came from, possibly in another country, with no memories of who you were? Mm-hmm. How is that evolutionary? How is that bettering yourself? We learn by our mistakes. Mm-hmm. We learn from the things we have done wrong and the things we've got right. My concept, called cheating the ferryman, gets over that problem. My concept of cheating the ferryman says, yeah, reincarnation happens, but you're reincarnated as yourself. You're not reincarnated as somebody in India. And not only that, but when you're reincarnated, a subliminal part of you, which I call the daemon, knows that you've been reincarnated and remembers your past life. Just like when you play a computer game and you have the on-screen sprite only remembers the game and then dies, doesn't it? You create the sprite and it does things. But the game player learns from that game, and next time round will take a different route around the game because it's learned. That's what I argue. Life is iterative. I'm not saying that reincarnation may not happen, but all I'm saying is, how does the process work? How does my essence go somewhere else and come back down somewhere else? How is that choice made? There's billions of people on the planet, millions of children born every day or whatever. What's the choice? Do I stand there and make a choice? Where am I making that choice from? Whereas much more simplistic is the idea, just before I die, I literally go into a virtual reality recreation of my life again. Mm-hmm. And again and again. So I don't even in my hypothesis, I don't even have to argue about how information is processed by a dead brain. Because if you're dead, you're dead. I don't have to argue that. I argue it all happens the final seconds of your life. So I don't need to even explain that. But my point here with reincarnation is one other point. And I've done great research on reincarnation, both the anthropology of it and everything else. Do you reincarnate straight away? You know, when you die, do you reincarnate straight away, as the Native Americans in the west coast of America believe? Or are you reincarnate? Do you go somewhere for a time and then you're reincarnated, as other religions believe? Or are you relocated into your own family, which some religions believe? Or are you reincarnated at higher or lower levels into animals, as the Hindus believe? Mm-hmm. But people turn around and say, oh, it's a universal. Reincarnation is, so many civilizations believe in it. No, they don't. They believe in completely and utterly different conflicting reasons of it. And if reincarnation exists, how can people who are mediums work? How does a medium talk to somebody who's dead if they've reincarnated? If your great aunt Doris is reincarnated as a donkey on the island of Patmos, how can your medium be talking to her? And yet people can keep those two conflicting belief systems in their head. They can believe in mediumship and they can believe in reincarnation. And I go, you can't. So they come up with some lame excuse and they say, oh, no, it's when you're between lives that you talk to great aunt Doris. Right? And your evidence for that is? Your scientific evidence for that is? And they don't have any. Because there isn't any. Yeah. But there is evidence that great aunt Doris can give information. I wrote a book with Irving Laszlo a few years ago. And one of the things I did the whole section on the history of mediumship and everything. clearly there is some information being transferred here, and there is communication transferring here. But if we're one single consciousness experiencing itself subjectively, I am Great Aunt Doris, and Great Aunt Doris is me. Again, in terms of mediumship, you know, everybody who's into mediumship should read a book called The Hungry Ghosts by a guy called Joe Fisher, where Joe Fisher was fooled by an entity that was supposedly being channeled by a medium. Mm. Self-evidently, whatever was going on, whatever the thing was, it was not what it claimed to be. And this is, again, where in my books and my latest work, I'm looking at this egregorial thing. The idea that the entities we contact into these circumstances are not what they seem. We think it's Great Aunt Doris, but is it just a projection of ourselves? Is it a projection of our anticipations? Having said that, I have witnessed probably 24 medium sessions with mediums. I have not seen anything that has convinced me of anything. Mm-hmm. There's nothing I have seen where I've gone, wow, I can't explain that. All I've seen is somebody cold reading, throwing things out, and then grabbing at something when they get there. You know, my mother once said this. She said, oh, you know, a medium once told me that, you know, I'd marry a man with an E in his name. And she said, look, Eric Peake. And I said, okay, Mum, how many names have got E's in them? And this is the game they play. It's the law of large numbers. You scatter things out. If the medium was a proper medium, they'd say, okay, Francis, you're going to meet a guy called Eric Peake. But they never do that. Or they'll go, I've got an elderly man in my head. He's pointing at a stick. He says his name is it's Bill or Will, or, and they've got a whole audience. And then somebody go, it's Uncle William. That's right. He's just said it's William. And you see them do it. And you speak to the people afterwards, and they say, wasn't that just incredible? And I turn around and say, you gave her all the information. Mm-hmm. Now, I'm not saying I'm dissing it, but, you know, let's have an open mind, but not so open mind that your brain falls out. Yeah. You know? Yeah, so that's my point on that. But I think there is it's much more interesting than this. These things are real. It's how we define real. And that's the billion-dollar question. Mm-hmm. And I think the idea that we are creating this reality, and I'd then counter-argue that if somebody genuinely wants to believe in mediumship, they create the environment where mediumship can be real. Mm-hmm. So in which case, they will see evidence everywhere, because this is the world they are in. This is the anticipatory world that they create. This is why I believe the people who are profoundly religious, every specific religious belief, they believe it not because they're naive, not because they're stupid. It's because they believe in it so much, it actually manifests. You know, for instance, you know, in 1917 in Fatima, when the sun span in the sky and came down, I suppose you know about that case. I heard about that, yeah. Mm-hmm. And people said that, you know, that it had been raining and it evaporated off the people around them. Something clearly was seen there by a lot of people. And I would say again, that was an egregorial consciousness creating that. The thousands of people that day wanted to see something, and they created it in external reality. And this is where the egregorial model is going. But clearly there is a lot here, and it's exciting times. It is exciting times. You know, there's no question about this. And in fact, you know, one of the things we were talking about before we started was the event I'm doing, not this weekend, but next weekend, called Contact in the Desert. Yeah. And this is the world's biggest UFO get together. I don't know if you've ever heard of it before. Do you know of it?
I've heard about it before. Yes, yes.
Good. Mm-hmm. And it's been going now for about 10 years, I think, and it happens every year. I mean, my sister and brother-in-law used to travel down from Canada every year for it, and I was invited to speak on it 2 years ago, but unfortunately, because COVID has hit, last year's was cancelled. And this year, the lady who runs it, Victoria Givoan, has invested a lot of money in some incredible software whereby it's going virtual. So all the speakers will be speaking virtually in a virtual environment that you log into and everything else as well. And there will be, I don't know, 70 lectures maybe from people like Whitley Strieber to, you know, so many famous people. And the researchers are at all areas and levels, you know, from the scientific to the different viewpoints. And I know that there's an intention that it will be moving into a more scientific, more rigid approach. And I'm delighted because of me, I've been able to facilitate 3 other speakers that will now be speaking at the event, including myself, of people that I've introduced to them. Mm-hmm. So we'll be having a friend of mine called Samantha Lee Treasure, who will be talking about entities, dream entities, out of the body experiences, the people you experience in out of body states, these kind of things. So that's quite intriguing. Then there is a guy called Jim Elvidge, who I've interviewed a few times on my own program. He wrote a book called The Universe Solved, which is about a simulation theory, which is the things I've been talking about. And really interesting, there's a guy called Dr. Andrew Gallimore, who is the most amazing. He is a neuropharmacologist, and his work on both aliens, dimethyltryptamine, is right out there. He's the guy that's right. He lives in Okinawa in Japan. He's English. Mm-hmm. I think he's actually from vaguely your part of the world. Okay. But highly intelligent, highly dynamic, and absolutely great fun. You know, he's an amazing character, and I managed to get him a slot on there as well. And in fact, last year, Andrew and I were supposed to be doing one of the workshops together, but we won't be able to do that now. But I'll be doing a lecture on my last book, The Hidden Universe. And I'll also be doing what's called an intensive, which will be on the Monday, which is a 2.5 hour, 3 hour intensive discussion on a lot of the things I've been discussing here, mm-hmm. but with much more information and with graphics and everything else as well, and a full PowerPoint presentation behind me as well to explain in detail exactly the things I've been saying here today. So if anybody's interested, you know, if you can get that up, but it's Contact in the Desert. It's going to be amazing. We're hoping that this year will be the only year we'll have to go virtual, and next year we'll be back down in Indian Wells in Southern California for the event, because normally you get 5,000 people turn up, maybe more. Mm-hmm. You know, it's a huge event. As somebody quoted, it's the Woodstock of the UFO world.
Yeah. Oh wow. Well, I'll definitely put like a link in the description to this video as well, so people can find it easier. So
okay.
Yeah, definitely. And thank you, Anthony, for your time. It's been brilliant and fascinating as always with yourself. And so thank you very much. Really appreciate it.
Wonderful. It's always great to talk to you. It's sad that we couldn't have got you down here for this one, because it's always great when you come down here and we chat informally out there in my conservatory, which is really nice. But yeah, really wonderful talking to you, Paul. And I look forward to meeting you again soon.
Oh, thank you, Anthony. Thank you very much.